Hello, hello, hello. Attention, ladies and gentlemen. Please, on a scale from 0 to 10, how is my audio? Mainly my audio. I can see Ricardo, Celina. Please let me know on a scale from 0 to 10, how is my audio? I hope you guys can hear me okay. This is a Q&A session as we had, thank you John, as we had last week. Yes. So sometimes I come here with a certain topic to discuss, but last week and this week I decided to use this time to take as many questions as possible. So please feel free to ask here as many questions as you want. I'm gonna start with a question from our last session, from our previous session last week about p-value. Yes. Unfortunately, I do not remember the name of the person that asked about this topic. P-value, very much important, very much important. Um, but I'll be talking about p-value first. But please feel free to ask as many questions as you want in our chat window here. I am trying to alternate between like east friendly time and west friendly time, and sometimes central. Yeah. So sometimes I run these at, I think right now it's 8, I think no, it's 8 p.m. Singapore. It is 12 p.m. Central, GMT. Yeah. And it is 9 a.m. for Brazil. Yes, 9 a.m. for Brazil. So let me get started. Let me get started with p-value. Yes, with p-value, and I'll try to present an explanation. As simple as possible. As simple as possible. Okay, and thank you so much, John. I can see Kandasamy. I can see Inês. I can see Osra. Thank you, Osra, for your question. Obrigado, Júnior Ramos. Bom dia. Bom dia. Wonderful. It's funny because yesterday I was teaching until almost midnight because we are running a white belt that is kind of America's time zone friendly. Yeah. So really to meet a good time for my friends in Mexico, in Latin America. Yeah. So the session starts 7 p.m. Central Standard Time, but this is 10 p.m. 10 p.m. for us in Brazil. Yeah. And it's amazing. It's always amazing. It's always amazing. Yeah. I feel fortunate. I feel fortunate because you guys give me this opportunity, yeah, to be your educator in Lean Six Sigma. I feel fortunate. Yeah. Wonderful. See, Rowan from Trinidad and Tobago. That's amazing. So, Trinidad and Tobago, I think right now it's 7 a.m. Is that correct? 7 a.m. or 7 a.m. or maybe 6 a.m. So let me talk about p-value first. P-value first. P-value will be very much useful. Very much useful. It will be almost mandatory. Yeah, almost mandatory. When, oh, that's amazing. That's amazing. 8 a.m. That's wonderful. Um, Mandatory when you have any sort of hypothesis test. So, what is a hypothesis test? Hypothesis test, hypothesis. So, a PhD thesis, is pretty much a statement that was validated. Yes, already. Hypo, it's less than, it's half. So hypothesis less than a thesis. So it's something that we still need to check. Yes? And every time that we are, let's say, making a decision, that we are judging something, every time that we are judging something, let's suppose I am stating that this cell phone is excellent. Let's suppose, or I'm stating that this cell phone will work. Yeah, will work. Every time that I present a statement, I have pretty much two types of mistakes that I can make. Yeah, I can make the conclusion that it works, but in fact it does not work. Yeah, and I can state that it does not work, but in fact it works. Are we good so far? Yeah, there are basically four scenarios. One that is, wow, I say that it works and it really works. I state that it does not work and it really does not work. I say that it works, but it does not work. I say that it does not work, but it works. Yes? Wonderful. So thinking in terms of it works, it does not work, I can argue that we have in fact two hypotheses. The first hypothesis is it works. And the second hypothesis it does not work. And I'm not gonna talk about null hypothesis, alternative hypothesis, status quo. I wanna keep it as simple as possible. As simple as possible. So let's try to translate this context to Lean Six Sigma. Yeah, because you will find hypothesis testing at least in two important moments in our DMake journey: in analyze to validate root cause, and in control phase to your final project validation, your final improvement validation, the famous before and after. Yes, at least. Because you have hypothesis testing, for example, in measure phase, measurement system analysis. Yeah? Wonderful. So root cause. I can argue. Let's suppose this is not working. And then I have a potential cause. It is not working because of the protection here, or because of the battery, I'm going to collect, very likely, I'm going to collect a sample, and make a conclusion based on this sample about the entire population. I will not be testing 100% of the phones. Very unlikely. It's very unlike that I test 100% of my phones. I'm going to test a sample. And based on this sample, I will need to present a conclusion that is, battery is the root cause, yes, battery problems is the root cause, or it is not the root cause. P value will present to us, in quotes, this is dangerous, because p value is not exactly probability, okay? This is a little bit dangerous. But in quotes will present the chance, the probability, the chance that you say, that you state that it is root cause when in fact it is not. If you are a Greenbelt student, you know that p-value, it's really the chance, the risk of you stating that no hypothesis should be rejected when in fact you should not reject. Yeah. So it's really a measurement of risk. you know? And we don't like to see this risk going above 5%. 5%. Yeah, so that's why we will reject null hypothesis when p-value is less than alpha, less than 0.05. Yeah, 0.05, it's a very common alpha. Yeah, you can use 10%, you can use 20%, but 5%, it's very common. Yeah, 0.05. So again, if you get a p-value that is 0.01, then you can say, wow, it's sampling, so there is always a risk. It's life. It's life, so there is always a risk. But what I am saying is, based on this p-value, the risk of stating that this is the root cause, and in fact it is not, yeah, the risk is very small. Very small. And the same thing in control phase. Yeah? In control phase, the null hypothesis, the status quo is process didn't change. Process did not change. Process is still the same. Yeah? So, maybe you have an argument to reject this hypothesis. Yes? And then you definitely take a look on your p-value. Your p-value would indicate to you, what is the chance that I state that, wait a second, the process has changed. I have improved my process, you know? The process has improved. You know? You are stating, and what's the risk that you are stating, but in fact, the improvement did not happen. What is this risk? Oh, it's 0.04. Okay, so it's less than 0.05. So you go ahead and you state, and then you say, you know? And then again, there are some important, let's say, considerations, you know, in this conversation, but keeping it very simple. So for example, you need to state, making super clear that your conclusion is based on a significance level of 5%. Just to give you an example. And there are important assumptions, you know, to use hypothesis testing depending on the test, okay? But please let me know if that was helpful. P-value, it's really the chance in p-value indicates the probability in quotes, or the chance that you, in the context of Lean Six Sigma, that you declare, that you state that it is a root cause based on a sample, but in fact it is not. And also it's the chance, the probability of you stating that the process has improved, but in fact it hasn't improved. Yeah? Was that helpful? Type here for me if that was helpful or not. And let me take the other questions. Just quickly. Nick, at this point, I do offer black belt courses in Portuguese, but we are almost done with the black belt course in English. So very soon we will have black belt in English. Okay? Very soon. Very, very soon. Yeah? So let me go back to the question from Yosra. For GB and BB, do we need to sign an NDA before we start a project? And do need to require the NDA from the champion process owner? That's an amazing question, Yosra. That's an amazing question. It's not mandatory. It is not mandatory. Mainly when you are leading a project in the company where you work for. Okay? So it's not mandatory. To be honest, it's not common. I have not seen, many situations where I had to sign an NDA. I remember there was a period in my career from 2008 to 2011 that I ran a lot of design for Six Sigma projects, so touching a lot of very critical topics in terms of innovation, disruptive innovation, you know. So we had many partners, universities here in Brazil, outside Brazil, many other companies, you know, that I remember that we reached out to 3 different welding machine companies here in Brazil and in Germany, and then for sure we had to sign. I had to ask them to sign an NDA. You know, guys, NDA, non-disclosure agreement, non-disclosure agreement. It's a kind of it's a document just to guarantee that nobody will disclosure, yeah, important information, because you'll be touching, very likely you'll be touching sensitive information, yeah, sensitive information. And there are, if you search on internet, you guys will find many many standard templates, yes, for non-disclosure agreement. And once again, the idea is that you somehow protect against leaking, yeah, information, important information to people that should not have this information. Okay, but it's not mandatory, yeah. For example, ASQ does not put NDA as a mandatory element. Okay, wonderful. I sent query via email. Oh, okay, let me take a look. Let me take a look right now. Did you send to support? I have a query on the analysis of a bell curve. Would you please open the attached file? I seem to have a little confusion in the analysis of a bell curve. While our aim is to produce a bell curve which is as thinner as possible, but when we analyze it in terms of process yield, it corresponds to only 68.2%. On the other, if the bell curve is wider, that would correspond to 95, 99%. Ah, okay. That's a good one, and this is a common topic. Okay, this is a common topic, and let me think in a cool way to explain that. And let me show. Is it okay? Can I show? Can I show the email that you've sent me? Is that okay? Let me just get the approval from Ricardo. Is that okay, Ricardo? It's pretty much the bell-shaped curve, yeah. And for a bell-shaped curve, like the that we used as a reference for the normal probability distribution, yeah. So let me show the exact request, okay. So see, this is the very famous, yeah, bell-shaped curve, and then you have like 68%. We are gonna approach 68%, yeah, let's say, of the possible values when we have one standard deviation to one side, one to another. Then 2 standard deviations would mean 99%, and 3 standard deviations 99.7. So the question is very interesting because it seems to be better to operate in one standard deviation because then the normal probability distribution is thinner, and we love to make this normal probability distribution boom like this because then we are reducing variation. And then it sounds counterintuitive to operate, with 3 sigma, 99.73%, because then the probability distribution will be going to the extreme. So I have an impression that the variation is increasing. So this is a common confusion. This is a common confusion, and let me explain this again in a very simple way. Ricardo and everybody, please keep in mind that the probability distribution, this shape, will always be the same. Will always be the same. So we cannot take just one part, just one piece, just one fragment of the distribution. We will have always the entire shape. Always the entire shape. So it's not a matter of having a probability distribution with one standard deviation. You can not have a distribution with just one standard deviation. There is always infinite. But normally we cut 3 to one side, 3 to another, because we are approaching 99.7% of the area under the curve. That represents, in simple words, the possible values. So the challenge, the thing is, how can you reduce variation, the value of the standard deviation, the absolute value of the standard deviation, to make your entire curve thinner? Again, it's not about taking one standard deviation. It's how to make your standard deviation, in absolute terms, smaller. How can you reduce standard deviation so your probability distribution gets, boom, thinner? And then you can, for example, fit within the specification limits. Let me open up Minitab and let me see if I can run an example here for you guys. Ricardo. So for example, data set 1, and then I have data set 2. Data set 1, data set 2. And then data set 1, I'm gonna generate. It is in Portuguese. Let me just change here for English. 1 second. That's what happens when you teach for a special global audience. Sometimes you are teaching in English. Sometimes you are teaching in Portuguese, right? So let me just change to English, and also the decimal symbol. Let me change it again. Beautiful. So now we have in English. So let's suppose we have here data set 1, data set 2. Okay. And then I'm gonna generate some random data, with mean. The mean is 10. Let me zoom in for you guys. So see, the mean is 10 and standard deviation is 1, okay? Mean is 10, standard deviation is 1. And then I'm gonna generate on dataset 2 mean 10 but standard deviation 0.2. So see, I have reduced quite a lot the standard deviation, yeah, 0.2. And then what happens, you know? What am I doing here? So when I run, for example, capability analysis, yeah, a capability analysis. With these two data sets, see, I hope this is helpful. Ricardo and everybody. See that I have a normal probability distribution here, and I have a normal probability distribution here as well. See, maybe from here to here, I have 3 standard deviations. And from here to here, I have 3 standard deviations as well. Yes, 3 standard deviations here and 3 standard deviations here. Oops, 3 standard deviations here and 3 standard deviations here. This size here, from here to here, I have 3 standard deviations. Let me change here to this screen. I think it will be even easier. See? So from here to here, I have 3 standard deviations. Yeah? And from here to there, I have 3 standard deviations as well. Yeah? Let me know, Ricardo, if that was helpful. So it's not about taking, you know, like one standard deviation to one side, one to another. No. We will always, you know, operate with this model of, you know, 3 standard deviations. The thing is, in the second scenario, 99.73% of the data points will be, yeah, in a much thinner, you know, yeah, we will be narrowing down. Yeah, we are reducing variation. We'll be narrowing down our normal probability distribution. Yeah. Let me know, Ricardo, if that was helpful. How can we purchase Minitab? Yeah, here I truly don't have the details. I work for Minitab, but on the technical team, I don't have details about the, you know, commercial, about the price. You can check on the website. But if you are a student, be aware that you can use a official Minitab version, yeah, on a website named On the Hub. Yeah, you can you can use a temporary version, 6 months, 1 year, for a much lower price. Like I think it's $29 for 6 months, you know. But you must be a student or a professor, yeah. If you are part of a corporate, if you work for a company, yeah, then please ask the procurement department to reach out to Minitab, because they have a discount, you know, due to volume. So if you have for your company 10 license, 50 licenses, the price goes down a lot. But I don't know what is exactly the price, okay? But I know for sure that there is a volume discount, and that there is there is, if you are a student or a professor, you can use the version in this website on the hub, okay? Can we say that the area under the curve is the same? Beautiful, André. So see, the area under the curve will always be 1, because it's a probability distribution. Will always be 100%. Yeah? Will always be 1. Always. And it's interesting because it starts on minus infinite and it finishes on plus infinite. So it's really it's tricky. It's tricky. Because then we are saying that everything's possible. And it's true, yeah. But let's say if you approach, yeah, in terms of normal probability distribution, minus 3 standard deviations plus 3 standard deviations, you are approaching 99.73% of the possible values, yeah. That is virtually 100%, yeah. Yeah. That's amazing. I'm glad to know you like it. It is the shape of the curve that confuses me. The distribution has nothing to do with the process yield then. Yeah, the shape, the shape, I don't know if it is clear that it's really about probability. Yeah, it's really about probability. So I am saying that there is a higher probability in this process here. If I select randomly a part out of these 100 parts, there is a higher probability that I reach something around 10. See? And then the probability goes down, yeah, when I go to the left and when I go to the right. So it's much harder to find a part that the value is 7, for example, or the value is 12, it's 13. You know, it's much harder. It's really probability. Yeah, it's really probability. And I don't know if I can say that it has nothing to do with yield, because mainly on a probability, on a capability analysis, you know, there is a connection with yield. You know, there is a connection with yield. For example, let's suppose in this example here, let's suppose the lower spec limit is 9. You know, it's 9. So see, the picture in terms of yield has changed completely, because now I have a lot of defects here. Yeah, defective items. I have a lot of defective items here. And in scenario 2, I don't have any defective items. Yeah. So there is a connection with Yud. There is a connection with Yud. Yeah. And see that sigma level, maybe one thing to clarify as well is that 1 sigma, 2 sigma, 3 sigmas, uh, we need to be careful in not making a confusion with sigma level. Sigma level is a capability index. Yeah, sigma level is not synonym of sigma. So sigma level, it's not the same of standard deviation. Sigma level is a capability index. Yeah, it's a capability index. That is, in very simple words, it's pretty much the distance between the mean and the closest specification limit divided by standard deviation. This is sigma level. So when I say this process is 5 sigma, it's 6 sigma. This process is 4 sigma. This process is 3 sigma. When I have this kind of conversation, I am talking about a capability index. I am not talking, when I say my process is operating at a 4 sigma level, it doesn't mean that standard deviation is 4. No, 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 no. No, no, no. Sigma level, it is not a synonym. It's not the same of standard deviation. We will be using the standard deviation to calculate sigma level. Yeah, and sigma level is absolutely connected to yield. Absolutely connected to yield. Yeah, sigma level. So, yes, yes, yes. So now looking to the table that you've presented here below, yeah, it's really the sigma here, it's sigma level. It is not standard deviation. I think that's the trick. I don't know, yeah, who presented this table, but this sigma here, it is sigma level. Yeah, and not, yeah, and not standard deviation, and not standard deviation. So meaning, let me just see if there is the 1.5 sigma shift, that it's definitely not recommended. Let me see. Okay, yeah. And apparently here it's just from, yeah, it's just from one side. Yeah, this is dangerous. This is dangerous, Ricardo. Yeah, this is very dangerous. Yeah, I would strongly recommend to be careful with this with this table. Yeah, with this table, because yeah, there is another way to explain this. Are you guys having fun? Yeah, this is a very important topic. Ricardo brought here a very important topic. Very important topic. Let me show in a different way. Maybe it'll be interesting. So I can take, for example, uh, see, let me, I think this explanation will be helpful. I think this explanation will be helpful. see. If I have a process, with, let's consider that everything in red is defective items, defective items. Yeah, defective items. So see that I have pretty much 16% of defective items to one side. Yeah, 16%. I have 15.87. It's 0.1587, but this is this is not in percentage. Yeah, and I have 15.87 here, and then I have just one standard deviation. So this is a way to connect. This is a way to connect yield, yield to sigma level, to sigma level. So see that in this case, I have 16 to one side, 16 to another, so 32, 1 or 100% minus 32 will be 68. Yes, so what is in here, it is good. What is in here, it is good. 68%, beautiful. But 68% of good parts, I think we can improve that, right? So let's suppose now we don't have sigma level equals to 1. We have sigma level equals to 2. See what happened. Yeah. So now I have only 2.275 to one side, 2.275 to another side. Yeah, and it will be almost 5%. Yeah, and that's why to sigma I have 95% of, let's say, good parts. Yeah, good parts. Wonderful. Now if I have 3, sigma level equals to 3, then I would have just 0.135 to one side, 0.135 to another side. So this is 0.27. So that's why we have that 99.73, the famous 99.73. 99.73, I have only 0.27% of chance of having bad parts. Depending on the process, this is amazing. Depending on the process, this is amazing. Yeah. So I hope, so sigma level equals to, this is what we call, John, the standard normal probability distribution, So I'm just trying to connect like the number of standard deviations to sigma level. But the easiest way for you to understand sigma level is consider just one specification limit, and it's the mean minus is specification limit, or specification limit minus mean, depending if it's a upper spec or a lower spec, divided by standard deviation. This is the simplest way to understand sigma level. When we have a lower and upper spec limits, then it's a different conversation. Yeah, then it's a different conversation. But when you have just one, just to keep it simple, it's that. Yeah. Yeah, I'm glad to know you guys like it. Yeah. Normally, I plan to stay here 1 hour, but this is so cool. This is so cool that I'll need to stay more. If you guys can stay a little bit more, I'll be here because I know there are other questions. And I want to reply as properly as possible. And I love to try to find different ways to explain the same thing. I don't know if you guys noticed here, I've used different learning approaches to explain the same thing, yeah? And this is by far one of the most relevant topics in Lean Six Sigma, by far, by far. So thank you, Ricardo. Thank you for your question, okay? And I hope it was helpful. This session is always recorded. I will keep it here so you can refer back, you can come back here and watch again what I did, you know, and listen again. All of you guys, okay? I hope this is helpful for you. We have participants from Trinidad and Tobago all the way, you know, to Malaysia. Thank you so much, Veronica. From Kenya. That's amazing. Africa. That's wonderful. Philippines. Could I apply to be your mentee? Yes, we are right now offering a white belt session, Augusta, and this is again America's friendly in terms of time zone. And every time that we offer a white belt, we will be opening up for green belts. You know, again, this is more focused to Americas, but you can apply. You can apply, okay, for green belt. And if you are already a green belt, maybe you can consider applying for our black belt program that that we will be launching soon, very soon, okay? Question: when is the best time, or in what situation do we have to use the make or the medif? Charlene, Paulo. Thank you, Charlene. That's a great question. So the make, when you want to improve current processes, when you have a process in place, yeah? The medif, define, measure, analyze, design and validate or verify. When you are starting, you know, the development of a new process or a new product from scratch, from zero, from scratch. So the medif, design for Six Sigma. But, Charlene, sometimes, in a demake project, when you reach out to analyze phase, sometimes depending on what you find in terms of root causes, depending on what you find, sometimes it's better to completely redesign your process. So sometimes on a demake project, you will prefer to completely redesign. You can promote what we call incremental improvement. You can promote what we call a process transformation, and here we are talking about structural improvements. So when you change, for example, machines, when you need to completely redesign the method, when you need to change your staff completely. So we call this, transformation, But you have another level that we call a disruptive improvement. Disruptive improvement meaning it's completely new, Now I have a process that is completely different. So the machines are completely different, the method is completely different, the raw material is completely different, and then in this case, it's the medif, Can we say also the risk to reject the null hypothesis is low enough since it is less or equal than 0.05? Yes, Manuel, you can say that the risk of rejecting null hypothesis is low enough. I like that. So you can go ahead and reject the null hypothesis. Yeah, you can say that. Yeah. The 68% is equivalent to 1 sigma to one side, 1 sigma to another. Yeah, one sigma and 1 sigma to another side. Yeah, and then if you take 2 sigmas to one side, 2 to another side, then you have roughly 95%. And if you take 3 to one side, 3 to another, 99.73. Yeah. Wonderful. Excellent. Perfect. Perfect. Can we apply Six Sigma without applying Lean? In companies that work great on mass production rather than lean production? That's a good point, Yosra. That's a good point. That's a great question. Uh, that's a great question. We are full of great questions here, as always. See, Yosra, by the book, we should apply Lean Six Sigma only to solve structural problems. Yeah, so only when we have very high complex problems with unknown causes and unknown solutions. But the thing is, we can use parts of Lean Six Sigma, fragments, tools, and techniques of Lean Six Sigma on our day-to-day activities, to solve like regular problems. It is okay, but by the book, it's only for high complexity problems. And going hand in hand with this conversation, we should apply Lean Six Sigma only when we guarantee that our basic homework is completed. What do I mean by basic homework? Quality system, like a set of SOPs, standard operating procedures, training, but high quality training, and audit. So that should be the foundation, that should be the foundation. In very simple words, I don't want to complicate. We should have a set of standard operating procedures for the key processes. Training, we should train, but world-class training, and audit, like checking if we are adherent to the procedures. So if we don't have these in place, in theory, we should not talk about Lean Six Sigma. We should do this first. But again, the thing is, we can take advantage of many, tools and techniques that are part of the Lean Six Sigma body of knowledge, for sure. And in line with this conversation, if we had to decide which one to apply first, I would definitely recommend to apply the Lean principles first. So if we had to separate Lean and Six Sigma, and I do not recommend you separating Lean from Six Sigma, but if you had to separate, definitely Lean first. Because Lean, you will be able, or Lean, you can maximize the chances of operating on what we call high impact, low effort area. So with Lean, many times you can promote, significant impact with minimal effort. With very simple tools and techniques many times. And Six Sigma, the classic Six Sigma, we know that it will imply in normally in more sophisticated and more complex tools. Okay. So yes, you can separate that. I do not recommend, but you can separate that. Yeah, very good point. Please explain USL and versus. Okay, so I believe it's USL, LSL, UCL, LCL. Yeah, so upper specification limit and lower specification limit, upper spec limit and lower spec limit, it's pretty much defined, stated by customers, defined by customers, stated by customers. Yeah, I want to have my cheese bread in max 10 minutes. Yeah, max 10 minutes. It's a specification limit I have specified. Control limits are calculated. Calculated. Yeah, using different formulas, different methods, depending on the control chart. And the idea of control limits, the idea it's really to help us to understand if our process is in control or out of control. Okay? Then, if we change the process, do we need to assess the risk and financial cost of our? Absolutely, 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 Yosra. Very much, very much. And you need to be aware, Yosra, that see, the make projects are by nature um, medium high risk projects. Yes, the make projects. The mediv are even riskier. Yeah, the natural risk of a demediv project is high by nature. Yeah, a demediv project has a higher risk by nature. Why? Because on a demake project, we don't know the solution. So we don't know what we'll find on improve phase. On a demediv project, we do not even know the voice of the customer. That's interesting. So it's even, yeah, more challenging. So the mortality rate of demediv projects, it's at least 3 times higher than the mortality rate of the make projects. At least 3 times. Yeah, so you definitely need to keep sharp eyes and assess risk as much as possible, um, including the financial aspect. Yeah. No, it's my pleasure, Charlene. It's my pleasure. Thank you, Osama. I'm glad to know you like it. So quality system management is mandatory. André Santos. Essa é a pegadinha, meu amigo. This is a tricky, this is what they call the $1,000,000 question. The $1,000,000 question. Buy the book, André. Buy the book, my friend. We should first of all guarantee that we have a proper, quality system in place. Buy the book. But the problem is, I mean, can we take advantage of elements of Lean Six Sigma? Even knowing, and the reason I am saying this is because I had a chance to work on a huge multinational company that had no quality system in place, because it was more of a tech company, more of a, not a startup, but a tech company, and then it's much more challenging, to apply to write down standard operating procedures to everybody, because things are changing, VUCA. Yeah, the volatility is huge. Volatility, uncertainty, complexity, and ambiguity. So it's hard, but at least a flavor, and that's what we did. But in parallel, we had a chance to run, OPEX projects, Lean Six Sigma projects, and it worked. It worked beautifully. So again, by the book, we should invest first on a quality system and then have a conversation about continuous improvement. Because it's like, yeah, it's hierarchy, André. It's really hierarchy. For example, I cannot set I cannot set objectives in terms of learning. Picture like you are educating your daughter, your son. You cannot have a conversation about learning a new language, about going to ballet, about going to swimming classes, if there is a major issue in terms of health, in terms of health. So it's really about hierarchy. We need to tackle. We need to tackle first things first. Yeah, the basic things, because if there is a health issue, I mean, it is nonsense to put on a swimming class because the person will not be able to swim. The child will not be able to listen and understand an English session, for example, or a Spanish session, a new language. Or the person will not be able to stand up, on a ballet class because depending on the health issue, So, yeah, yeah. First things first. And this is funny because, yeah, unfortunately, there is a lot of distortion in Lean Six Sigma. Unfortunately, a lot of distortion, a lot of because of marketing, yeah. And that's why many people simply do not understand Lean Six Sigma. They simply do not get it. And then they position Lean Six Sigma as something that will solve all types of problems, yeah. And this is not true. Lean Six Sigma was not created to solve all kinds of problems. Lean Six Sigma is limited by nature as any other method. And Lean Six Sigma is focused specifically on problems with unknown solutions. So Lean Six Sigma should be applied specifically for projects with unknown solutions. So when we picture, for example, a project portfolio in a corporation, we will have all sorts of problems. What we call Nike project, just do it. Nike project, just do it. So very straightforward, projects. We'll have demanding projects, create things from scratch, pure innovation, disruptive innovation. We'll have the make projects, high complex the make projects, super high complex. So for black belts, medium high complexity project for green belts, so all sorts of different projects. But this is under the umbrella of continuous improvement. But there is another umbrella that is quality management. And in this quality management, there is a pillar that is related to BAU, business as usual. Like, how do we do the basic things, and then we need to have, some sort of quality system. And again, in very simple words, a set of standard operating procedures, training, and an audit. Yeah. So when we start running Lean Six Sigma projects, and then we see that the root cause is lack of training. No. Lack of training, or lack of SOP, or non-adherence to SOP, or when we start seeing things like that, it suggests that there is some homework that we did not do, and then we need to do this first. And that's where, for example, automotive sector is very mature. Automotive sector normally is very much, mature in this aspect. Yeah, it's a good reference. I think pharmaceutical company, from what I am seeing, it's getting there as well. It is getting there. But automotive sector, they are very much mature. Yeah. Calé Anders. Tudo bom, meu querido? Beleza? I'm sorry, guys, for speaking up some Portuguese sometimes, just to give a hand, to my friends in Brazil. It's a virtual high five, right? Thank you, Yosra. Thank you very much. What's the difference between Lean Six Sigma and Six Sigma? That's a great question. So, yeah, Six Sigma was created in 1980s in Motorola, yeah, and Lean Six Sigma was created in 2001. And it's really Lean Six Sigma. It is more Six Sigma. This is a good point. Yeah, Lean Six Sigma. There is more Six Sigma than Lean, and it's pretty much Six Sigma with things like respect to the people, value stream mapping, waste reduction, the lean solutions. Think in terms of lean solutions. Yeah, very much important. So it's really Six Sigma with elements of lean. Professor, what's the acronym for the other more challenging projects type? Yeah, it's DMADIV. DMADIV. So it's define, measure, analyze, but then design and verify. Define, measure, analyze, as we have for the make. But then we have another D for design, that stands for design, and then verify. And DMADIV, it's really when you are not fixing a current process, you are creating something from scratch. Yeah. Professor, you have an amazing way of explaining complex matters in simple words. I don't get enough. Thank you so much, Ozra. Thank you so much. I appreciate your work, your words. Okay. Professor, does it mean if the solution is unknown for a particular problem, it is compulsory to apply? That's a good question. That's a good question. Because then you came the other way around. Yeah. Lean Six Sigma is for problems with unknown solutions. But see, I have an answer here that is commercial. I could be here arguing that yes, Lean Six Sigma is the only method to solve structural problems. But it is not. It is not. You will find, Mazibuko, other methods to solve structural problems. There is one named Shining. Yeah, and they don't have belts, but I think they have like things, red X, I am not an expert in Shining, but I know it's a method to solve structural problems as well. Yeah, from what I know, from research, as a researcher, and as a practitioner, because I am in the Gamba. I am running I do run projects. I don't know any method more robust than Lean Six Sigma for solving problems with unknown causes. I don't know. Yeah, but it is mandatory to apply Lean Six Sigma? No. When you face a problem with unknown solutions, you can use other methods. You can guess. I do not recommend guessing. You can apply PDCA, but my recommendation is Lean Six Sigma. Lean Six Sigma based on facts, based on my life, I mean, my entire professional career was built running Lean Six Sigma projects, you know, and you guys can check the number of publications about Lean Six Sigma. It's very you will not find another method that has the same number of, for example, publications for structured problem solving than Lean Six Sigma. You will not find. So it's by far the most famous, and I think there is a reason for that. There is a reason for that. Because it's very beautiful, like the mechanism of from macro to micro. So you diverge and you converge. You diverge, you converge, So Lean Six Sigma has a lot of that. You diverge on potential problems, then you narrow down to the most critical problems, using, for example, pyramid structure. Then you map your process, you see a lot of critical process steps, and then you narrow down to the most critical process steps. Then you deep dive in these critical process steps and find a lot of critical potential causes. And then you converge to the most critical potential cause and to the root causes. Having the root causes in hands, you diverge again to potential solutions, and then you converge to the best solutions, your action plan. So see this convergence, divergence, convergence, divergence. You converge and you diverge and you converge, diverge, converge. This is powerful. This is powerful. This is so powerful. This is so beautiful. And when you mix Gamba data, Gamba and data, Gamba data, Gamba data, go to Gamba, talk to people, talk to operators. This is gold. You need to master Minitab. You need to master Minitab. But in the same level, you need to be good with people. You need to be able, you need to be capable of having a good coffee and a good 1 hour conversation, 30-minute conversation with an operator. You need to know how to ask the right questions and let them speak. And you need to truly value, even if sometimes it sounds difficult to digest, Yes, even if sometimes the operators sound annoyed, irritated, and as a consequence, sometimes they will offend you or say something that potentially offend you. Even if these kind of things happen, listen to them, and sometimes you'll be just quiet. And you guys know about the expression active listener. Be an active listener, but be also, let me see how to translate, if that translates to English. Let me see if that translates. Yes, empathic listener. So listen with empathy. So what is this? When you listen with empathy, more than checking the content, you are checking the feeling. I just came from a project. And there was a very aggressive, and I have problem with aggressiveness. I have problems. I don't like aggressiveness. I don't like. But I saw that the aggressiveness was coming, with a reason. So you need to find what is the root of the aggressiveness, and try to feel what the operator is feeling when you listen, and not simply listening, waiting for your time to speak. You know, truly listen. If you are my white belt student, if you were my white belt student, you know, it's really the situation with John. You know, listen to John. Maybe John has something important to say, and it comes pretty much from Lean. Six Sigma does not talk a lot about, listening, respecting the people. Six Sigma, it's really more about data analysis. That is important as well. It's very much important that you master as much as possible, Minitab and statistical analysis. But it's equally and maybe a little bit more important. It's at least equally important that you know how to listen to the people, because many times the solution is there. Many times a good one-to-one coffee with the right person is more valuable than a 2-week Kaizen event that you put 30 people in a meeting room, a lot of post-its and flip chart. And I'm not against Kaizen event, but many times a good one-to-one conversation with the right person will be much, much more valuable than a fancy and sophisticated Kaizen event. Listen to the people. Go to Gamba, collect data. Go to Gamba, collect data. Yeah. I see more pharmaceutical and chemicals companies demanding for Lean Six Sigma. Yes, André. I don't know, André, if you are based out of Brazil. If you are in Brazil, yeah, pharmaceutical and mining company, mineradoras. Mineradoras, they are hunting good belts. Yeah. Thank you, Vindra. Thank you. Mazibuko, structural problems, it's really problems with unknown solutions. Yeah. It's really chronic problems, high complexity problems. Yeah. Have you used turtle diagram instead of SciPoc? No, I have never used. Yeah. It is okay to learn Lean Six Sigma only, or it is better to learn Lean Six Sigma and Six Sigma? No, Charlene, the Six Sigma content is embedded in Lean Six Sigma, okay? Maybe one thing to consider is, if you want to deep dive more on the Lean concepts, maybe you need to find later on a pure Lean training, but a good Lean Six Sigma training will definitely address Six Sigma very well, yeah, or at least it should address, yeah. They know the daily troubles in process. Yes. So there is a CIMED, André. CIMED it's a huge pharmaceutical company. They are doing an amazing job. I have many students there. I have students in União Química as well. So yes, the pharmaceutical companies are doing an amazing job. Guys, that's it. Almost 90 minutes. I went a little bit, yeah, a little bit, let's say above my upper spec limit of 60 minutes. I hope you guys had fun as much as I had here, and on top of everything, I really hope it was helpful and the tips and the answers were helpful for you. Okay, thank you so much. Thank you, Vindra. Thank you so much, Charlene. It's always a pleasure to be here with you guys. If you want to go back to this session and take again, I will keep it here in my YouTube channel. If you are not a subscriber of the channel, please subscribe to our channel, and then you guys will get notifications every time that I am live. Yeah, and it will be a pleasure to have you here as part of my YouTube channel. Okay, thank you so much. Thank you. I'm glad to know you guys liked it. Thank you. Gracias, Ricardo. Thank you so much. Gracias for your question. Bye bye, guys. Thank you all for all your questions. Bye bye.